Hello students, Ms. Slyman here with your notes. I'm going to do example 4 here, but I just wanted to note in example 3, part 3, if you had graphed this in your calculator, you would have found the 3 roots of -1, 1, and 2. Notice here this shape. It looks, if we had zoomed in closely around here, we would see that it looks almost like a cubic. Well, if we had found the roots algebraically, and I've shown how to do that over here, we factor by grouping and then synthetic division based on the one we saw here, factor by grouping again, and then difference of squares. Notice x minus 1 is a factor that appears 3 times. So x equals 1 is a repeated root. Here it repeats 3 times, and we end up with a shape that looks like a a cubic. Remember when we had a repeated root up, we looked, I think, here? When a root repeats only twice, then it looks almost like a quadratic. So now we're saying when a root repeats 3 times, it looks a bit like a cubic. So let's use that idea down here. So I see 3 single roots. My roots are going to be x is -2, +1, +3. So -2, +1, +3. When, so this is x equals -2, y, -2, 1, 3. That's when y equals 0. When x equals 0, then our y value is going to be 2 times -1 times -3, which is +6. I know that this is going to be we have a leading coefficient of +1. Our n, our degree, is 3, so it's going to have the shape of a cubic, something like this. And without using my calculator or calculus, I don't know where my maxes and mins are. So all I can really do here is just try to match my graph. So I have to go through all my points. Again, I don't know where the maxes and mins are. I'm just putting them randomly. So on a non-calculator paper, a picture like this would be fine. On a calculator paper, I would go in and I would find where my maxes and mins are. So let's do that. So I'm going to put in let me get rid of this. Okay, so y equals, clear out what I've got here, x plus 2, x minus 1, x minus 3, and then I'm going to set up my window to match, so -5 to 5, counting by ones, and then -10 to 10, also counting by ones. Oh, looks like I did pretty okay with my sketch. So it looks like down here I'm coming down about as far as 1, 2, 3, maybe about as far as 4. So here I could come back and extend, let's extend that down a bit, somewhere around 4. And then my max looks like it's sort of above 1 at about 8. Sorry, -1, somewhere like that. And of course I could use my calculator to find those values more exactly. But for now, this is fine. And without the calculator paper, just going through our key points and having the shape of going from down to up is fine.